Hello everyone, good evening and welcome to the class. Yes. Happy Ganesh Chaturthi everyone. Good evening and welcome back all of you. Yes, happy Ganesh Chaturthi to all the class teachers as well. Yogesh sir, Anil sir, Anshul sir, welcome to the class. Rami Malwache. Thank you for asking. Ankona. Okay. Hi, seeing you after a long time. I'm here like at least twice a week. You can see me. Sir, have you ever played for Manchester United? Sir, can you speak Bengali? I can understand a little bit. Tami ek to Bangla jani. Sure, end में बात करेंगे. Everyone will speak about things which are not related to physics at the end of the class as always. Shall we start, all of you? Good. Everyone is ready? Write class one in the chat box. Cool. Okay, so guys, this is our session number 4 and session 4 of rotational motion. Last time we started our discussion about torque. From there only the continuation will happen. Just revising previous class notes. Okay, that's good. Very nice. Okay, so as always, I'll switch off the chat now. Try to focus on the screen first. As in when the time will come, I will be open to take the doubts. The good part is we have only one topic to cover today. If the time permits, I will pick something from the next upcoming session also. Okay. Sure, everyone. Switching off the chat. First of all, a quick recap of what we did last time. Last time also we didn't do much of theory. Actually, the entire mechanics. I like mechanics only probably because of this reason that it doesn't require much of theory to do problem solving. So we are in that pool. We are already in that phase where not much of theory is to be studied, but whatever is to be studied has to be understood, and more of its application is done through problem solving. Okay, so we are in the most important chapter, that is rotation motion. And last time we spoke about torque, and torque was understood as the rotational effect of force. Okay, or it is also known as the moment of force. That too about axis of rotation. So we understood that this torque, whenever it acts on a body, say this is the body and this is its axis of rotation. Okay, so on this object, say if there is a force which is acting and this force is trying to rotate the body about this axis of rotation like this, then if I know the position vector of the point where the force is acting, then I can always write down the torque as the cross product of r and f, can also be written in terms of magnitude as r into f into sine theta. And I explained you how you can split it into 3 possibilities. One is r into f into sine theta, other one was r into f sine theta, where f sine theta was the tangential component of the force, or r sine theta into f. These are all mathematically the same thing, but practically while solving the questions, we saw how different these physically mean. Okay. Also, very importantly, if your force will ever pass through the axis of rotation, if any of your forces is passing through axis of rotation, it won't be able to rotate the body. The torque will become 0 because of that. Then we spoke about the possibility of rotational equilibrium. ठीक है अंश, आज सॉल्व करेंगे कुछ क्वेश्चंस वापस से, तब समझ में आ जाएगा about line of action of force. It's very simple. We'll understand it today itself. Okay. So we spoke about the rotational equilibrium problems. We finally concluded it by 3 points. First of all, you will simply draw the free body diagram of the object that you're trying to simplify and understand. Second thing, you will try to first talk about translational equilibrium. If a body is in equilibrium, it has to be under translational equilibrium and rotational equilibrium. So first we'll try to write only translational equilibrium, which means the net forces acting on the body should be equal to 0. If the job is done by that equation itself, will not require the rotational equilibrium equations. But as we saw in the previous class, that there are situations when I will require to also talk about the torque acting on the body to be equal to 0, and that is what we call as the rotational equilibrium. More importantly, I told you that you can balance the effective torque value to be 0. You can balance the torque acting on the body about any point. About any point means you can choose any point as axis of rotation. Okay, so that's a very important point. I told you that's one thing which will help you, and in fact, we will always choose that point as our axis of rotation. Okay, we'll choose that point as AOR, where maximum forces are acting, so that their torque becomes 0 about that point and becomes easier for us mathematically to solve the question. Okay, so this is what we did last time. Let's have a quick round of questions, and then we will actually be continuing today only with respect to more of application of torque. Okay, so all of you try to solve these questions. Question number 1 on your screen. If the torque, find the torque because of the force is given 7I cap minus 3J cap 5K cap, and that too about origin, which acts on a particle whose position vector is given. That means r vector is given to you. Question is trying to say that maybe wherever the position vector is formed of this point, that is where you are applying the force. So r vector is going to be the position vector of the point where the force is acting, and there you are applying a force on the body maybe. However, you are applying the force, this is force F. So this point is basically what is trying to rotate, and you're trying to calculate the torque which is acting on this particle P, which is located at 1, 1, minus 1. So forget about the diagram. Diagram is just to tell you that about O you are trying to do this because this is the point where axis of rotation is. Origin is the axis of rotation. Okay, so I am going to give you guys 90 seconds for this. Apply determinant method, and your time starts in 3, 2, and 1. Close to 30 seconds are remaining now. Last 5 seconds, all of you. Okay. Okay. Let's see how we were supposed to solve this. The correct answer is option C, as you can see. So if we arrange our vectors R and then F in this manner, we can always write down the value of cross product. So I cap component is going to be -5, -3 I cap. After that, for J cap, it is -7. Okay, so first we did this. Now we are doing this -7 and +5 J cap, and last is -3 -7 K cap. That means -8 I cap, -2 J cap, and -10 K cap. So as simple as this is the answer. Okay. So one more before we start our today's session. You have to find the torque in the given figure. We have an object, maybe the point or axis of rotation is given, and this is where the force has been applied. The force is 10 Newton. The position vector, the line of that position vector, if I extend it, okay, it is making an angle of 30 degrees. That means if I bring my force vector here, the angle between force and R vector is going to be 30 degrees. This is your R vector, 2 meters, force is 10 Newton. Angle between them is 30 degrees. Find out the value of the torque, giving you 60 seconds, and the time starts in 3, 2, and 1. Okay. Time's up. Very good. Okay. And correct answer is very easily doable. I'll actually show you all the 3 ways in which we can solve this question. The first approach is just to write down R, F, and sine of 30 degree. So value of R is 2, F value is 10, and sine 30 is half. So the value comes out to be 10 Newton meter. Less than 20 seconds, you can answer this question. But if I want to say go by the approach when we try to write it as tangential component of the force and accordingly solve this, right? So I'll do one thing, everyone. I'll first try to resolve the force, and for doing that, I need to talk about the point where force is acting. So this is the point where force is acting. So if the point experiences the torque, it will definitely move in this imaginary circle. So now you see the value, or rather the force which is acting. You can resolve this force into 2 components. Let's draw the 2 components now. Okay, so one of the components is going to be along this direction, and one of the components is along this direction. Okay, so this is F cos 30 degree and F sine 30 degree. Which one is the tangential component? Sine or cos component? Which one is the tangential component? Or just by looking at the diagram, which component is going to rotate this point in the circular path or rotational motion? Definitely sine component. You see that now it is acting at an angle of 90 degree. So by method 2, I can say that the torque is going to be F sine 30 degree. You will see that mathematically sir is going to write the same thing. Okay, that is 10 half 2. Answer is still 10 Newton meter. Obviously, there is no change in the answer. Okay, now the third approach. Okay, those who find the line of action wala part difficult to understand, you guys especially pay attention. Can I say that this is the line on which the force is acting? This is that line on which the force is acting. All of you, correct? There is no doubt in that. Correct. Now do one thing. Drop a perpendicular from O, the axis of rotation. Drop a perpendicular on this line. This is how that perpendicular will look like. Correct. Good enough. So now force will not be changed. This is your R, and you have to talk about the perpendicular distance between point A, point O, and say point Q. Can you find out the value of D? Okay. Can you tell me what D will be? D is basically R sine 30 degree. That is 2 into 1 by 2. So D value comes out to be 1 meter. So what do we think torque will be? Torque will be equal to F into D. And F into D is 10 into 1. Answer comes out to be same by all the 3. So whichever approach you want to or you're able to apply, you will just go by that. Question will never tell you that apply this method only. You have all the liberty. Okay. All 3 methods clear to all of you? Once again, बहुत बढ़िया, very nice. Chalo, so we'll start with our today's discussion and we'll solve. First of all, we'll talk about what is torque equal to I alpha. Perpendicular foot method, यही तो है. ये perpendicular foot method ही तो था. और कौन सा method है ये प्रियांशु? But you wrote a question mark after that. पुरुषोत्तम, कौन सा मेथड? ये वाला. तो इसमें हमेशा 2-3 स्टेप याद रखने. द फर्स्ट मेथड, फर्स्ट स्टेप इज, सबसे पहले तो यू हैव टू एक्सटेंड द लाइन ऑन विच फोर्स इज एक्टिंग. फोर्स जहां लग रहा है उस लाइन को हर तरफ, लेफ्ट में भी राइट में भी, मतलब जहां भी फोर्स दिखाई दे रहा है वेक्टर, उसको आगे और पीछे दोनों तरफ उसकी लाइन को बढ़ा दो. ठीक है. आफ्टर दैट जहां भी एक्सिस ऑफ रोटेशन है वहां से उस पे परपेंडिकुलर डाल दो. ओके, उस परपेंडिकुलर की लेंथ निकालो, उसको मल्टीप्लाई कर दो फोर्स से. दैट्स इट. सिंपल 3 स्टेप्स. ठीक है. ओके, पुरुषोत्तम का डाउट क्लियर हो गया. बट वेयर इज दिस गाय? प्रियांशु, अभी क्लियर? चलो बढ़िया. So guys, let's talk about tau equal to I alpha. As you already know that there have been already so many quantities where translation and rotation counterparts have been spoken about. If you people remember, if in translation, the role was played by displacement. What is the quantity that does the same job in rotation? It's theta, angular displacement, right? Here it is displacement, and in rotation it is angular displacement. If there used to be velocity in translation, it will become omega, angular velocity. If it used to be linear acceleration, it will become angular acceleration alpha. क्या बात है? The role which was played by mass there is played by moment of inertia, capital I. The role that was played by force there will be played by, or is played by, torque here. Shabash, बहुत बढ़िया. So in the same sense, everyone, in the same sense, can I say that the role which was F equal to ma has to become tau equal to I alpha? Yes. Perfect. So first of all, we'll derive it. We'll not just simply accept it. We'll derive it and then we'll use it. That's the only theory we'll study today. That means अगले 3 slides की theory है, फिर कोई theory नहीं है. Okay. Already happy. So switching off the chat so that we focus on the screen. So if you have not just a single force, say multiple forces acting on a body. Or what I'm trying to tell you that maybe when I try to rotate this bottle, or maybe when I try to rotate this bottle, each and every particle of this bottle is going to experience certain force. Then only that's why it is rotating, right? One very important thing that we know is, like in translation motion, when the body translates, when the body is moving like this, it's a translational motion. When the body moves, it is moving such that all the particles have same displacement, same velocity, same acceleration. In rotation motion, when the body rotates, all the particles have same angular displacement, same angular velocity, same angular acceleration. That means theta omega alpha is same, except for the particles which are on axis of rotation, because they are not rotating at all. So when this body rotates, maybe you are applying force only at certain portion of the body, but definitely for every particle to move, effectively there is a force which is acting on that particle and creating a torque. So we basically want to come to that part, that if multiple forces are acting on a system of particles or probably a rigid body, then we can consider they individually will try to apply torque on that particle where they're acting. Okay, so see how it affects and brings us that equation. So maybe this is my rigid body on which I'm considering it is made of n number of point masses. Point masses m1, m2, m3, m4, m5, m6, mn. Multiple point masses may not be considered to be of same mass also. M1, M2, M3 are different masses. So when this entire body rotates, the entire body has the same angular acceleration as I said. So all particles except the one which are on axis of rotation are basically having the same angular acceleration. The total mass of the body is maybe m, and nothing else is required. So maybe when all these particles are looked at, when this body rotates, different particles, m1, which is at a distance r1 from axis of rotation, we know that when the body is going to rotate, different particles of the body will move in different circles, right? When the door rotates, the handle of the door moves in a circle which is of radius r, but the midpoint of the door rotates in a circle of radius r by 2, like that. Okay, so different particles of the body are going to perform their own circular motion, and they have different radii also. So say as per the diagram, if you look, you'll find that m1 particle is at a distance r1 from the axis of rotation. Maybe it is experiencing force F1. Okay, and the force that I'm talking about is the tangential component of the force only. All the forces that I'm talking about are the tangential components. Okay, so m1 is experiencing F1 force acting at a distance r1. M2 is experiencing a force F2 which is acting at a distance r2. Like that, every particle shares the total force which is acting on the body. So if I want to write down the net torque which is experienced by the entire body, I can say it is r1 into F1. Sin 90 I'm not writing because all these forces are tangential component of the forces. So directly I'm simply writing the tangential component multiplied by the radius. So r1 F1, r2 F2, r3 F3, like that for the nth particle rn Fn. Okay. Also the linear acceleration of the particles is given to be equal to alpha r. These three equations are always valid here. I forgot to mention it here. S will be equal to r theta, v will be equal to r omega, and a will be equal to r alpha. These will be valid during translation motion. During rotation and translation being combined together, or when they are compared with each other. So in this case, when we are speaking about a is equal to alpha r. So now what I'm going to do is I'm going to write the force acting on the first particle as its mass into linear acceleration. Similarly, for the second one, I'll write its force as its mass into its linear acceleration. F equal to ma is what I'm writing. So like that, if I keep on writing, the last particle has mass mn, acceleration is am. Right. Now what is a? A is alpha r. So for all the particles, I can say r1, or let's first write mass. So m1 r1 and a1 I can write as alpha r1. Right. Alpha is same for all the particles. Similarly, m2 r2 alpha r2. Like that, m3 r3 alpha r3. All the particles I write that for. So I'm mn, the last particle, rn into alpha rn. So what you see here, the first one is m1 r1 square. Alpha I'm going to take common. Second one is m2 r2 square. Like that, if I keep on writing, this is what I'm getting. And alpha taken common. So what is m into r square? All of you, for point masses, what do we understand by mr square? Is it the moment of inertia of the point mass? So can I say that addition of all these is basically the moment of inertia of the body? And this is the overall moment of inertia of the body only, right? So that's why torque is equal to I alpha. That's what we get. That's the equation that we were waiting for, and we derived it also if you require ever. Okay, good enough. But yeah, chalo chai. Let's see some questions. Switching off the chat so that we focus how they are applied basically. So the first one is very easy. A torque is given. In fact, ये solve torque is given, alpha is given. It is asking for moment of inertia that you have to find out. I'm setting up the quiz. You start solving because I'll give you only 30 seconds. Okay. And setting up the quiz now. We will give you only 30 seconds. Find out the value of I. And the time for 30 seconds starts in 3, 2, and 1. Let's see. Simple math question, that's why. Class 5, come on. That's it. Expecting huge correct response on this one. Very good. And okay, little less than expectations, but okay, not bad. So I will be equal to tau by alpha. Torque is 2 into 10 to the power minus 4. Alpha is 4. So 0.5 into 10 to the power minus 4 kg meter square. That's our answer. Okay. Now let's see this example. In this question, it says that there's a flywheel. Flywheel, generally, I want you people to remember this term or keep a note of it, because many times you will find questions which will use this particular word to talk about a disc. This is just a very cheap attempt to confuse you. That many students who have not heard about what a flywheel is, they are not sure in the examination that is it a disc the question is talking about, or is it a ring that it is talking about. So it's a disc. What flywheel means? Okay. So a flywheel of mass 25 kg has a radius of 0.2 meters. What force should be applied tangentially to the rim of the flywheel so that it acquires an angular acceleration of 2 radians per second square? So diagram supportive, in support of it, I have also drawn practically, or rather, actually the diagram was not drawn there. I have drawn this diagram here so that I'm able to also correlate it with the question itself. So this is where the axis of rotation is, the usual center, that is your axis of rotation. Okay, and you have like some string which is wrapped over it, which is being wrapped over it, and you're pulling that. Okay, 14th of January, सबको पता है ना, मकर संक्रांति. It's that thing. Spool is what we call it. है ना? तो kite पे मत ध्यान दो, जहाँ मांझा रहता है मैं उसकी बात कर रहा हूँ. है ना? So this is something of that sort, maybe just for visualization purpose. It is actually a disc that we are talking about. And if I'm going to pull the string, can I say I'm actually applying a force? Everyone, I'm applying a force, and that force will always be tangential. Doesn't matter where it is going to be, it's going to be a tangential force. Perfect, thank you. Right, everyone. So this force is to be found. So question is saying that mass of the body is there, and I want to talk about torque, and torque is going to be F into R. Can we say that? Torque will be equal to F into R, because the angle between force and R is already 90 degree, and this should be equal to I alpha. Good enough. This is a disk whose moment of inertia, half m r square, yaad ho gaya ab tak to, right? Into alpha. So you see R and R got cancelled. Force comes out to be m r alpha by 2. Just solve this. Mass of the body 25 kg. R value is 2 by 10. Value of alpha is 2 divided by 2. So 2 cancelled it. 50 by 10 comes out to be 5 Newton. That's our answer. Simple. Hi, बोलो. कितने दिन हुए मेरी क्लासेस में आके, पहले तो ये बताओ. कितने दिन से मेरी क्लासेस में आ रहे हो, ये बताओ. रेगुलर हैं? तो मोमेंट ऑफ इनर्शिया नाम का कोई चीज होता है, पता है? तो डिस्क का मोमेंट ऑफ इनर्शिया क्या होता है? समझ गए? तो नोट्स खोल के रखिए मोमेंट ऑफ इनर्शिया के. अलग अलग ऑब्जेक्ट के मोमेंट ऑफ इनर्शिया की जरूरत पड़ेगी आज. ओके, सो आई होप बाकी लोग भी समझ गए होंगे. एवरीवन एल्स अंडरस्टूड दिस. सो द आंसर केम आउट टू बी ऑप्शन सी. नाउ पे अटेंशन. दैट वाज अ डिस्क, नाउ इट्स अ रॉड. It's a rod which is hinged over here. It's a rod which is hinged over here, and because of its own weight, it's going to go down like this. I'm not doing anything to it, because just of its weight, it's going to go down like this. Okay? Go on. Rotation plus translation. Anyway, can you people tell me the moment of inertia of the rod about this axis? Moment of inertia of the rod about this axis. दक्ष चौधरी मैं ब्लॉक कर दूंगा. दक्ष चौधरी तुम ब्लॉक हो जाओगे बच्चे. एक बार पेश करो बस उसे. So 1 by 3 ml square is the moment of inertia. तो ये यूज करना पड़ेगा हमें. ठीक है? Can you people tell me where the what is the distance between axis of rotation and point of application of force? Distance between point of application of force and axis of rotation. Is it L or L by 2? Is it L or L by 2? L by 2 है. Clearly समझ में आ रहा है. Because we know that mg will always act at the center of mass. That's why. Exactly. That's it. कुछ नहीं करना है. Angular acceleration then. Tau equal to I alpha. How will I write torque? Torque will be the tangential component. Is the force acting tangentially in this diagram? How do I know is it acting tangentially or not? Let's check that. वो एक valid point है. Let's check that. Let's say that this is the point P. Pay attention. This is the point P, and point P at this instant, only at this instant you have to draw, not a moment before or a moment after. Let me draw the circle in which it is supposed to move. This is the circle. Axis of rotation should be the center. Okay, axis of rotation should be the center. Okay. By the way, this capital R is the normal force. Let me write it as capital N, so that we don't get confused with radius and this thing. So this is capital N. Okay. Now people tell me, is mg tangential in this given diagram? Is it acting tangentially? Yes. So there is one more force, normal. Will you write the torque because of normal? Why will you not write the torque because of normal? Because it is passing through the axis of rotation. It is passing through the axis of rotation. That is why you will not write the torque because of that, because उसका R 0 है. बिल्कुल, absolutely. ठीक है? Yes. तो चलो लिखते हैं. Torque which is equal to I alpha will be written for mg, and mg का perpendicular distance, so it is only the tangential component acting at a distance r. What is the moment of inertia? 1 by 3 ml square alpha equal to mgr. What am I getting? L as m and m got cancelled. अरे यार, r का वैल्यू तो लिखना पड़ेगा हमें. R का वैल्यू तो लिखना पड़ेगा. L by 2. Okay, so 1 L got cancelled. What do I have? 3g by 2 L. Is it what we are getting? 3g by 2 L. Yes, everyone. It's only calculation part. That's not what you come to this class for. Good then. This is how we solve questions. Let's try a few. What do you say? Okay. Time for you guys to try. Okay. Daksh Chaudhary. पहली बात तो you don't have to read the chat. First of all, you don't have to read the chat. Okay. And you are asking others to not put smileys. You yourself are spamming on the chat box. Okay. If there is something which is worth, which is written on the chat box, I myself highlight that thing. Okay. Sure guys, taking you all to first quiz from this topic. Question has the same diagram. It's a disk, and the force F is acting here on the hinged pulley. Find the angular acceleration of the disk is what you have to find out. This m alpha is to be found. I'm not telling you what is the moment of inertia of the disk about this axis. Few slides back we have used it. I'm giving you all 60 seconds though, and the time starts in 3 and 2 and 1. Okay, time's up. Moment of inertia is half m r square per disk. After that, nothing else was to be done. So, all of you, the torque is going to be F into R, because force is acting at a distance R from the axis of rotation. Okay, and this will be equal to half m r square into alpha. So F into R is equal to half m r square into alpha. One R gets cancelled. Alpha comes out to be 2F by mr. That's it. Answer is option B. Okay, another one for all of you. A grindstone has a moment of inertia of 6 kg meter square. What is a grindstone? Chakki, atta chakki. Okay, basically two discs which are placed over each other. If you, and the lower one is fixed, the upper one is rotated over the lower one. So whatever comes in between, it gets grinded. That's how in your maybe your grandparents' generation used to get the wheat flour, and nowadays it's all mechanical. So that's also mechanical, but now the machinery has changed. But this is what grindstone means. Okay, so the grindstone basically a disc for you people. It's basically a disc. Has a moment of inertia of 6 kg meter square. A constant torque is applied on it, and the disc is found to have a speed of 150 rpm, rotations per minute, not the SI unit. Okay, so after 10 seconds, its omega becomes 150. Initially, the omega was 0. You have to find out the value of torque. So find alpha, put it here, and simplify it. Obviously, you need to write the value of moment of inertia, which is given already. Giving you all 90 seconds. Time starts in 3, 2, and 1. Last 30 seconds, all of you. Okay. Mhm. So let's find out the value of alpha. First, we need to talk about omega, which is given to us as 150 rotations per minute. So how many radians in one rotation? How many radians in one rotation? 2 pi. And how many minutes? 60 minutes. Sorry, how many seconds? 60 seconds in 1 minute, right? So this 0 gets cancelled. This cancels 3 times. This comes out to be 5 pi radians per second. This is omega 2. Okay. So omega 2 is 5 pi. Omega 1 is 0. And the time in which it is changing this velocity is 10 seconds. So alpha value comes out to be pi by 2 radians per second square. Are we clear? Everyone got this? Pi by 2 radians per second square. Correct. So now I need to just put it here to get the value of torque. Moment of inertia is 6. This is pi by 2. So my answer is 3 pi Newton meter. That's it. 3 pi Newton meter is the answer. But yeah. Sure. अब आने वाला सबसे इंटरेस्टिंग क्वेश्चन, सबसे चैलेंजिंग क्वेश्चन ऑफ द डे सो फार. Okay, the most challenging question so far. I'm not saying this is the most challenging question ever. The challenging question it is. You will realize it after looking at it. So we have solved a question similar to it, but in that the rod was horizontal. Now the rod is making some angle that is 37 degree, and mg is still acting vertical. That's what mg does. And the question is asking you similar thing, that is finding the angular acceleration of the rod. Okay. Basically, you will require to either talk about foot of perpendicular, or you will require to find out the tangential component of the force at this instant when the rod is making an angle of 37 degree. Only thing that I can confirm, that moment of inertia of the rod will be 1 by 3 ml square. 1 by 3 ml square is the moment of inertia that you will use in this question. The rest I'm not speaking anymore. Giving you 2 minutes and the time starts. 3, 2, and here we go. Come on, people. Don't rush. Don't rush. Okay, jaldi nahi karo. Aram se solve karo. Make sure that you are reaching to the answer and you're absolutely sure that's the answer. Okay. Question requires actually you to think more rather than mathematics. Mathematics will not be much. I'm giving the value of sin 37, cos 37, whatever you require. पुरुषोत्तम, लाइन ऑफ एक्शन वाले मेथड से कर दो, फुट ऑफ परपेंडिकुलर वाले से, उससे भी हो जाएगा. स्पेशली तुम्हारा नाम लेके इसलिए बता रहा हूँ क्योंकि तुमने डाउट पूछा था. 1 more minute is left, so still can be done very easily. Last 10 seconds now. And time's up. देखते हैं कितने लोग कर पाए. ये देखा जल्दबाजी का नतीजा. जो लोग जल्दी करने की कोशिश कर रहे थे मिस्टेक कर गए. And I don't know, majority people thought that the answer will be 3g by 5l. All of you switching on the chat, but only respond when I'm asking you. Okay. Is this the line of action of the force? No, it is not. Is this the line of action of the force? Green line. The green line is the line of action of mg. No, that is the line on which mg is acting or not? Right. The dotted line that you see, is it perpendicular from the axis of rotation? The dotted line is perpendicular, right? Thank you. See this, all of you. Can I say R is L by 2 and this is D, the perpendicular, foot of perpendicular? D will be equal to how much? Can I say R cos 37 degree? Right? Not sine, cos 37 degree. So everyone, this is L by 2, cos 37 degree is 4 by 5. So it is 4, 2L by 5, right? So I have the foot of perpendicular now. So how do I calculate the torque? I calculate the torque by multiplying force with D, the foot of perpendicular. I have समझ में. So just a second. Guys, Okay guys, so the value of force will be mg, है ना, and this will be equal to I alpha also. So mg acting at a distance 2l by 5, moment of inertia 1 by 3 ml square, correct? And this is alpha. So L gets cancelled, M gets cancelled, alpha comes out to be 2 into 3 into g by 5l, that is 6g by 5l. That's the value that I'm going to get, right everyone? पहले ये बताओ समझ में आया क्या आदित्य राणा और बाकी की जनता? पहले बताओ ये वाला मेथड समझ में आया क्या? नहीं आया तो जिनको नहीं समझ में आया वो इग्नोर कर दो, मैं दूसरा मेथड बताता हूँ. जितने लोगों को मेथड नहीं समझ में आया इग्नोर कर दो. आई विल टेल यू द अदर मेथड आल्सो. ओके, मैंने एक्सप्लेन करूंगा इसे दोबारा. आई विल एक्सप्लेन यू अनदर मेथड इफ यू डिड नॉट अंडरस्टैंड द फर्स्ट वन. दिस इज द शॉर्टेस्ट वन एंड ऑब्वियसली विल रिक्वायर योर ओन विजुअलाइजेशन आल्सो. ठीक है, अब दूसरा मेथड, ऑल ऑफ यू, द अदर मेथड. दिस इज mg and this is the point P which is having the force acting on it, the center of mass basically. So can I say this is the circle in which it is moving? Right everyone, you see that the force is not tangential. Force is not acting along the tangent direction. Do we all see that? Mg is not acting in the tangential direction because this is r. You see that this is r. R ka value, can anyone tell me one more time? R will be L by 2. Thank you. So this distance is L by 2. So now I need the tangential component of the force which is acting. Can I say this is how the tangential component is going to be? Do you guys realize sometimes you guys ask stupid things when I'm explaining something? Not keeping the chat on now. So this is the tangential component of the force, and for that I will require this angle. I will require this angle. Okay. और मैं यही नहीं पता लगाना चाहता था, इसीलिए because I did not want to get into the explanation of how this angle comes, I explained you the third method first. Okay. But if you did not understand, that's totally fine. Focus here. Now, to find this angle, you will actually require just simple basic geometry. So you know that this angle is 37 degree. So this remaining angle is 53 degree. So can you people again confirm what is this value of angle again? If this was 37 degree, this is 53 degree. Can I say this is again 37 degree? Correct. So this is mg cos 37 degree. Okay. Perfect. Thank you. Can I now say this is the tangential component of the force acting at a distance L by 2? So now I can directly write down the torque. So torque will be equal to mg, rather ft acting at a distance L by 2 will be equal to I alpha. Everyone. So tangential component of the force is mg. Cos 37 degree ka value is 4 by 5. L by 2, moment of inertia 1 by 3 ml square, and alpha. Simplify, you'll get the value of alpha as 6g by 5l. Simplification part I'm leaving for you guys now from here. ठीक है? जो तुम्हें इजी लगे, which one you like, okay? And अंश, तुम क्या मतलब पैरेलल यूनिवर्स की फिजिक्स लगा रहे हो? यही तो किया है मैंने, और क्या किया है? ये डी और क्या लिखा हुआ है? ये वही है जो तुम बोल रहे हो. L by 2 का कॉस कंपोनेंट लिखा है वो. आदित्य राणा, ये वही है. फर्स्ट मेथड वही था. हाउ स्लीपी आर यू टुडे? ये वही मेथड है जो तुम बोल रहे हो. पहले वही एक्सप्लेन किया था. ओके, हाँ, तो रिप्ले देख लेना. ठीक है, ओके. चलो, एवरीवन अंडरस्टूड दिस पार्ट? ऑल गुड, ऑल हैप्पी? दोनों मेथड बता दिए, जो लगाना है वो अप्लाई करो, टोटली अप टू यू. ठीक है सर, ये सर्कल किस जगह पर बनाना है? ये सर्कल कहाँ बनाना है? सही जवाब अपूर श्रीवास्तव, एकदम सही जवाब. पेपर पर बनाना है, कागज पर. एकदम सही जवाब. अब ये सवाल तो मुझसे एंड में पूछना, ठीक है? तो इसका सीरियस वाला जवाब तब मिलेगा, क्योंकि आज तुमने वैसा सवाल पूछा है जो कि रामायण मैंने पढ़ाई थी अगली पिछले क्लास में. लास्ट क्लास में मैंने रामायण पढ़ाई थी, और आज तुम मुझसे सवाल पूछ रहे हो कि सीता किसका फादर था. तो जब ऐसे डाउट होते हैं, हाँ एग्जैक्टली, तो मैं नहीं बताता उसको, स्ट्रेट फॉरवर्डली आंसर नहीं देता. ठीक है, चलो. अब बहुत ज्यादा जनता बेकाबू हो गई है, सब लोग चैट बॉक्स पे एकदम जोर शोर से स्पैम कर रहे हैं. सो आई एक्चुअली स्टॉप द चैट फॉर सम टाइम एंड विल जस्ट मूव ऑन टू अदर टाइप ऑफ प्रॉब्लम सॉल्विंग. एंड इन फैक्ट पीपल होप यू गाइस रिमेंबर दिस डायग्राम. आई एम श्योर सबको ये हॉन्टिंग मेमोरीज होंगी इसकी, सबके पास है ना. अभी प्यार आ जाएगा सबको, हॉन्टिंग मेमोरीज याद आएंगी अपनी अपनी. याद आई हॉन्टिंग मेमोरीज? कौन सा चैप्टर था ये? Which chapter was this? Laws of motion. What was the biggest condition about the pulleys that we used over there? What was the biggest condition about the pulley? Mass S. And I told you guys that we will come back to this situation in rotation motion. I don't know whether you remember or not, but that time has come. आ गया वो समय. आज we are going to solve that question where pulley will have the mass, and not only it will have mass, it will have moment of inertia. Okay? Yes. Okay, let's go. So everyone, same question. We basically want to find out the value of acceleration of the two masses. Okay, so मान लेते हैं, let's assume that m1 is greater than m2, that means this mass will come down and this mass will go up. Constraint equations are still valid. That means what? The string is still massless, still inextensible. Okay, string is still massless and inextensible. In theory of physics, that will only have mass in that question which I showed you some time back. String is ideal, but the pulley has mass, and the mass of the pulley is small m. So everyone, Now the pulley has mass. When the masses will move, when this mass will come down with an acceleration a, this mass will have to go up with the same acceleration a. Why? Because if the string is moving on the right side, it has to move by the same amount on the left side upward. So then only the string remains inextensible. Then only string remains ideal. So that is why both the masses will move with the same acceleration. First of all, there will be no constraint questions in this chapter. There will be only single pulley or straightforward questions you will come across. But the only part is now the pulley has mass. So the only point is, when we used to solve the questions earlier, we used to consider that the tension throughout the string will remain the same. We used to say that tension on the right side, tension on the left side, and the entire string will remain same. But now, because your pulley has to move, can I say that if my masses move with an acceleration a, the pulley also will rotate with an angular acceleration alpha, such that a will be equal to alpha r or alpha will be equal to a by r? Can I say that? This has to be valid. Okay. What I'm trying to tell you is, if the radius of the pulley is r, then when the masses move down by a distance 2 pi r, how much my pulley rotates? Can I say 1 revolution my pulley rotates? Exactly, that's what we're trying to communicate here. But the only thing is, people, if masses are accelerating, pulley is angularly accelerating. Do you agree? If masses velocity will increase, pulley angular velocity should increase so that omega will be equal to v by r. This should also remain equal or valid at any given point of time. Now the biggest of the trouble that you will face or we need to first overcome is that if I, by the way, what is that force which is making the pulley rotate? What do you think will that force be which is going to rotate the pulley? Definitely not mg. Definitely not mg. Why not mg? Because mg is passing through the axis of rotation. Yes, actually force of friction. But who's bringing that force of friction? Can I say the string which is wrapped over the pulley? Can I say that the string which is wrapped over the pulley is making the pulley rotate? Right? So if it is force of tension which is going to rotate the pulley, these are the two tension forces which are acting on the pulley. The string. You might have seen this in movies. Maybe that's how lassi is made at home in Punjab, right? So this is how this happens. My only trouble is if both the tensions are equal, which we used to consider so far. I see that this tension is trying to rotate the pulley clockwise. Remember, this tension will try to rotate the pulley clockwise, while this tension is trying to rotate the pulley anti-clockwise. And you can see both of them are acting at the same distance r. So what will they deliver? They will deliver zero torque. They will deliver zero torque. If they deliver zero torque, that makes alpha zero. If alpha becomes zero, a becomes zero. That means overall situation flop. So that's not going to work. Which means what? Buttermilk. Lassi is buttermilk. Okay. So the understanding which we have to make clear here. Okay. I'm not removing this part. This will stay for you guys to always recap. The understanding that we'll have to remember is on the right side of the pulley, the tension is T1. On the left side of the pulley, the tension will be T2. Tensions have to be unequal. Exactly, Apurv. Tension is going to be unequal, absolutely. But everyone, on the right side, A to B, the tension will be T1. On that part of the string, the tension will remain the same. And from C to D also, the tension will remain same, that is T2. You have to remember this. Why unequal is what I have explained it here. If the tensions will not be same, there will be no torque. And we want the torque. Why do we want the torque? Because we want the angular acceleration. Why do we want angular acceleration? Because we want acceleration for the masses. That's what question we want you to find out. Okay, got it? Aaya samajh mein? All of you are, look at the diagram once. After that, we'll draw the free body diagram. According to the question, M1 is greater than M2. So maybe M1 is coming down. So M2 will go up for sure. So how will the pulley rotate? How will the pulley rotate? If M1 is coming down, M2 is going up. Can I say pulley will rotate like this? Then only the possibility will happen. Okay. Exactly, Aditya. Earlier I said that there is no friction also. So if there is no friction, the pulley is not rotating at all. Okay, everyone is clear so far now? Previous slide ka matlab ye wala. Tensions are different. Please remember, tension A to B and C to D are different. Tension in AB is not equal to tension in CD. Remember that. Here the tension is T2 or maybe T1, and here the tension is T2. They're not same. Please remember that. If you're not able to understand. Basically, I have given you the explanation already. You can actually go through it once more. Tension in AB will remain the same. Okay. Sir, if mass is same, then T is same, then we can't calculate when mass is same. एक ही बात को तुमने पहले ऐसे बोला, फिर ऐसे बोला, फिर ऐसे भी बोला. Same बात बोली तुमने 3 बार. He is saying if M1 becomes equal to M2, if M1 becomes equal to M2, there will be no rotation, there will be no motion only, there will be equilibrium. If M1 becomes equal to M2, there will be equilibrium. Okay. Yes, so I'm explaining it now, everyone. So we have understood this so far. This is the diagram we see that on both the blocks, the tension will try to lift them up. The tension will try to not let them free fall. Basically, what I'm trying to say, if you cut the string, the masses M1 and M2 both will fall. If you cut the string, so both of them are being supported by the force of tension. We understand the direction of tension on the masses for sure. But on the pulley, both the tensions are trying to bring the pulley back or pulley down. Okay, pulley is actually being supported somewhere here by maybe the ceiling on which it is supported. Wait. Yeah. So this is the reason why your pulley is hanging. So this support is being challenged by the tension forces downward. Okay, or you can see that if two people are hanging on both the sides of pulley, the pulley will have a tendency to fall down because of these two tensions. Okay, those tensions may be developed by some other reasons. Okay, guys. So I hope so far we are clear with the diagram. Masses are M1 and M2. M1 is coming down, M2 is going up. Only because question is saying M1 is greater than M2. If M2 will be greater than M1, we'll consider M2 is coming down, M1 will go up, does not matter. Acceleration will be independent of that. Okay, so numerically, direction wise obviously will be affected. So now I'm going to draw the free body diagrams. Going back to NLM. As I said, this chapter is going to test all the chapters that you have studied so far. Already it has tested work per energy, center of mass, it has tested vectors, calculus, and circular motion also. So let's go to NLM also. So in addition to the free body diagram of M1 and M2, I'm drawing the free body diagram of the pulley also. So you see that this is the axis of rotation of the pulley. Obviously the pulley will rotate about its geometric center. So that's why you see the axis of rotation also. Guys, have a look at the free body diagram. Are you all able to understand it? M1, mg is acting downward, tension acting upward. Okay. Okay. Riddhiman, ruk jao bacha. Okay. Are you all able to understand the free body diagram of the pulley? One more force is acting on the pulley, by the way, here, but we don't care about that force. The force which is applied by the support, we don't care about that force. Why? Because that is acting on the axis of rotation. That's why. That is passing through the axis of rotation. We don't care about that force. The pulley is anyway not translating. It is only rotating. That's why. Mg of pulley is useless. That's what I'm saying. All the forces which are acting on the axis of rotation, those are useless. Pulley का mg किसी काम का नहीं है. Okay. चलो बहुत बढ़िया. Now I will write down the equations. The new thing that we will be learning is when we try to write down the equations. So far we used to write down F equal to ma. Remember, we used to write down F equal to ma for the blocks. Okay. मैं chat switch off कर रहा हूँ because you guys, instead of asking the questions to your CT, you guys are asking all the doubts in the chat box. You guys know my method today. I'm deliberately keeping the chat off, but you guys are making it difficult today. Sorry. So I will keep the chat off now. So pay attention. I will write down the F equal to ma equation for the masses first. So let's write down for m1. The mass is coming down, so obviously mg is greater than tension T1. So how will I write the equation? I will say it is m1g minus T1, which is equal to m1a. I'm not going to explain how we write this equation. If somebody will ask me, I will give you a virtual slap today. Okay? Yes. Second one is m2, for which the mass is coming up. So definitely tension T2 has to be stronger. So T2 minus m2g will be equal to m2a. The net force acting on m1 and m2, we have equated them to their mass into acceleration. I don't think anybody will be having any trouble writing these equations. Now the new equations that you will add on when you speak about a pulley with mass is the equation of tau equal to I alpha. Okay, these are the equations which you have written as F equal to m is. Now you're writing tau equal to I alpha. Okay, just a second. I'll just write these two things with other colors so that you guys, when revise, you understand that these two equations are F equal to m is. Okay, EQN is equation. Okay, and now I'm writing tau equal to I alpha equation. So everyone, we understood that if pulley is going to rotate clockwise, then T1 should be greater than T2. Then only that rotation is possible. T1 has to rotate fast. You yourself try to visualize, if the pulley has to rotate clockwise, then T1 has to pull stronger. Okay? So we will write T1 acting at a distance r, this is clockwise torque, minus T2 trying to rotate anti-clockwise. So T2 into r is the anti-clockwise torque. So I'm considering torque of T1 positive. So naturally torque of T2 has to be written negative because one of them is clockwise, another one is anti-clockwise. And this should be equal to I alpha. Okay? So let me take r common. T1 minus T2 into r will be equal to I into alpha. Alpha is basically A by r. Okay, all of you. So I get T1 minus T2 equal to I by r square into A. That is my equation number 1. This is my equation number 2. This is my equation number 3. And I want to find out the value of acceleration A. How much is the acceleration of the blocks? Okay, so we have got these three equations. T1 minus T2 equal to I by r square into A. Then we have m1g minus T. Okay, m1g minus T1 equal to m1 and T2 minus m2g equal to m2a. So if I will add these three equations, you will see T will get cancelled. So I'm taking it on the next page so that we don't create a mess here. Okay. So equation was T1 minus T2 equal to I by r square into A. That's my equation number 1. Okay. So all of you, what I'm going to do now, I'm going to add all the three equations. When I add all the three together, you will find that T1 will get cancelled with minus T1, T2 will get cancelled with minus T2. So what you will be left with is what I'm going to write now. M1g minus M2g, minus plus minus when multiplied remains minus only. So M1g minus M2g equal to, on the right hand side, I have M1 plus M2 plus I by r square into A. So acceleration equation is M1g minus M2g upon M1 plus M2 plus I by r square. That's basically the response or the answer to the given diagram upon M1 plus M2 plus I by r square. That's basically the response or the answer to the given diagram. This is not a standard answer. This is just the answer to the given situation that we have solved. Okay, this is the situation that we were solving. अभी बोलो, समझ में आया? अच्छा, in the diagram, if m1 is greater than m2, can I say that weight of m1 is trying to make the system move? Can I say m1 का weight m1g? This m1g, can I say is the driving force? Can we say that m1g is trying to drive the motion? And is there any force which is trying to oppose this motion or oppose the rotation of the pulley? Can I say m2g is trying to oppose it? All of you, m2g is trying to oppose it. Okay, correct? Got it? Do you see that I'm still explaining? Are you in my class for the first time? No, right? So you know that I keep the doubt open and then I take the doubts. So please, and if you want to write down the value as m r square, you will write it down. There is no crime in doing that. But please wait for me to open up for the doubts. Okay? So everybody, m1g is the driving force, m2g is the opposing force. Okay? So this is the final response that we have got. This is the final result that we have got. Okay? A generic answer in front of all of you. In a given system, if you are able to identify the driving force and the opposing force, there could be more than one driving force, there could be more than one opposing force, there could be more than two blocks, there could be more than one pulley. But the total driving force minus the net opposing force divided by the total mass of the block and the net moment of inertia of, or rather the moment of inertia of pulley 1 divided by its radius square. Okay, yeah, driving force is helping force. Okay, so if you are able to digest this formula, you can use it. Okay, yes, so if you are able to digest it, you can memorize it. If you are able to understand it, you can memorize it, and you will be able to save some time in the questions. Okay, all of you. Yes, so let's see an example like this question in front of all of you. Okay, pay attention now. So we have this question which has not one but two pulleys. Okay, for your kind information, pulley is equal to disk. Okay, so guys, you have two pulleys. One has mass 1 kg, radius 1 meter. Other one has mass 2 kg and radius 2 meters. We have 6 kg mass and 2 kg mass which are hanging on the other sides or opposite sides of the situation. The diagram has already mentioned that 6 kg block is coming down with an acceleration a and 2 kg block is going up with an acceleration a. So naturally, the pulleys are going to rotate in clockwise manner. Okay, so clockwise is the sense of rotation. The thing is, the angular acceleration of both of them will be same, but their angular accelerations will be definitely same. Okay, so the thing is, there is definitely one approach that you can go by writing F equal to ma for both the blocks. Then you will have to write tau equal to I alpha for both the pulleys also. So you'll have to write actually 4 equations. Then you will be able to solve it. The only part that I want to highlight separately, we will not be approaching this question by that method. Here, if I want the pulley number 1 to rotate, then obviously if I consider the tension here as T1, then definitely the tension here has to be T2. T1 and T2. Can you people tell me if pulley is rotating clockwise, which one is greater, T1 or T2? Can you see that T1 will be greater than T2? Then only pulley will rotate clockwise, correct? And now, because the pulley 2 also has to rotate, and between two pulleys, the string will have the same tension T2. On this side, I cannot consider the tension to be T2. I'll have to consider the tension as T3. Now, T2 will be greater than T3. So, why will you require 4 equations? It's because you have 3 different tensions, and you have acceleration also unknown. So, 4 unknowns are there. So, you will require 4 equations to write down. And we don't want to do that. We don't want to do that. Definitely, we don't want to do that. So, what will we do? Which one is the driving force? Which one is the driving force? Definitely, 60 Newton is the driving force. Because of that weight, only the system is moving. And which one is the opposing force? 20 Newton. Sorted. Okay. Perfect. Now we require I by R square, the moment of inertia divided by R square. And for a pulley, the moment of inertia is half mr square divided by R square. So this value comes out to be m by 2 in general. Are you getting it? When we are speaking about the pulley, you will write I by R square as m by 2. The only thing is, for pulley P1, for pulley 1, the value of m by 2 is how much? This is pulley 1 is equal to 2 by 2, 1 kg. This is your pulley 1. This is pulley 2. And for pulley 2, m by 2 ka value will be 1 by 2. That's it. That's it. The total mass is 2 plus 6. Basically, we'll be applying this method now, this formula. Oh, it's already there. So everyone, the driving force is 60 Newton, opposing force is 20 Newton, mass of first block is 6 kg, mass of second block is 2 kg, mass of rather m by r square for first pulley is 1, and the same for the second pulley is half. Remember? So what are we getting? This is 40 divided by 6 plus 2 plus 1, that is 9, 9 plus 1. 9 plus half is 9.5. Can I say that is 19 by 2? That's 19 by 2, correct? That means 80 by 19. Can I say it is 8g by 19? It has to be given in terms of g. So that's an answer already. That's an answer already. But definitely as a practice, you can try the question by writing those 4 equations. Okay? Okay, all of you? Definitely, you should try. But yeah, okay. Okay, so this one is done. We understood this. Another example for all of you. This is a question from JEE Main 2017. This question, let's first read it and then we'll try to solve this question. Question says that a uniform disk of radius r is having a mass m. Its mass is also given, radius is given, and it is free to rotate only about its axis. Okay, so basically it is again the similar kind of situation that your disk is there, and this is the kind of situation. All of you, this is the kind of situation. What I'm highlighting right now, because some people will ask me this question that what is this diagram? So this part that you are able to see here, green portion, is just the hinge. This is what is happening with the pulley. This is what is happening with the pulley. Okay, so my fingers are basically those green portions. Those are basically just creating the pivot. P-I-V-O-T, pivot. Pivot is basically hinging of something. Okay, so the disk is there, mass is given, radius is given. A string is wrapped over it, and just like that kite flying thing, spool. Okay, chakri. So this string is wrapped over the pulley, and the other end of the string has a mass m, block m, which is hanging. So when you release this thing, the block starts to come down, and definitely the pulley starts to rotate, and pulley will start rotating anti-clockwise. And why will it be rotating is because of the motion of the mass, and it's the force of tension which will create the torque for the pulley. And the same tension force will try to resist this motion. Okay, so question is asking us to find out the acceleration of the body. Okay, we have to calculate the acceleration of this body coming down with an acceleration a. Okay, I have not tried it by the shortcut. We will try it, but first I want to show you how it is done without that, by using the free body diagram only. So obviously I will write down F equal to ma, which will be mg. The mass of the block is small m, and the mass of the pulley is capital M. So small mg minus tension is equal to ma. Okay, and for the pulley, I will say that tension acting at a distance r is creating the torque. Okay, T acting at a distance r is the torque, which will be equal to I alpha, and alpha we will write as a by r. Okay, all of you understand the 2 equations so far? The first one is F equal to ma, the second one is tau equal to y alpha. Okay, moment of inertia of the disk half mr square. Likh de. So half mr square, and alpha I'm writing a by r. Do you see that both r square are getting cancelled with r? The other 2 r values are cancelling the r square value. This r square cancels with these two r. What you will be left with is t equal to ma by 2. T equal to ma by 2, not mar by 2 but ma by 2. Okay, सादे के फान मैंने वही कहा, पहले हम ऐसे सॉल्व करेंगे फिर हम उसे ट्राई करेंगे. ठीक है, so we have the two equations. I'll just simply put t equal to ma by 2 and simplify this. So see this, putting up here tension, when I put it here in the equation, it comes out to be small mg minus capital ma by 2 equal to ma taken on the other side, a taken common. Have a look. Let's try by that approach, that acceleration is equal to driving force minus opposing force. So there is no opposing force here because string is wrapped over it. So what is the driving force? I see that the driving force is mg, right everyone? The driving force is mg. The mass of the object is small m. The moment of inertia of the disk is mr square by 2 divided by its mass. Sorry, divided by r square. Dimensionally galat ho jayega, ठीक है? So what am I getting? I'm getting mg divided by m plus m by 2. Answer comes out to be 2 mg divided by 2 small m plus capital M. Is that the answer also? But yeah, so that works here also. But only thing is you need to identify driving force properly and opposing force properly. Okay, तो उससे भी आ गया. Okay, चलो everyone, one more question. Okay, नोट करने का टाइम मैं नहीं देता, क्वेश्चंस के लिए तो बिल्कुल नहीं. A slender uniform rod, I don't know the literal meaning of slender, but basically a rigid rod is what they are talking about. A rod of mass m and length l is pivoted at one end. सबको इस वर्ड का मतलब पता है? Everyone understands the meaning of pivoting? Hinging. Look at the door in your room. You will find 3 or 4 hinges there. 3 or 4 hinges. That's basically pivot. Okay? Yeah, actually. Fine. Okay. So there is a rod which is hinged over here. It has been hinged. That means what? It is something of this sort only. I'm hinging it right now, this pen. So it is going to move like this. So in our case, it is vertical. It is basically making an angle theta with the vertical and moving in the vertical circle. It says that there is negligible friction at the pivot and the free end is held vertical above the pivot and then released. So earlier your rod was vertical and then it is released. So it starts falling like this. Question is saying that when the rod is making an angle theta with the vertical, what do you think will be the angular acceleration alpha of the rod? So nothing else. We just need the equation tau equal to I alpha. Okay. Only thing that we need to understand that the rod is moving because of its own weight, that is mg. Final expression does not have m for a reason. The moment of inertia 1 by 3 ml square. The center of mass at L by 2. So at this instant we have solved a very similar question. You have to find out it with respect to theta now. Not earlier the value was given as 37 degree. So now you have to solve this. I'm going to set this as a quiz. Try to find out the value of angular acceleration. You have moment of inertia, you want to find out alpha, just write down torque properly, you'll be able to get this easily. Okay, you are free to use any of the method of writing torque by resolving mg or by writing for torque perpendicular, totally your call. I'm not giving you any restrictions on that. Giving you 90 seconds though, and the time starts in 3, 2, and 1. Forty seconds remaining. Come on, everyone. Okay, time's up. Okay, so yeah, you will realize that this is actually this question only. This is actually this question only. Only thing is the angle is theta and it is made with vertical. That's the only difference. It's actually the same question. Okay, so let's see how you will do it. So this is the line of action of the force. Correct? Can I say the value of d is L by 2 sine theta once again? This time, the right angle triangle I will show you. This is the right angle triangle. This is L by 2 hypotenuse, and this is d. This is L by 2 sine theta. Correct? Absolutely your call, everyone. So mg into L by 2 sine theta. Okay, mg into L by 2 sine theta. When I write that, this is basically f into d that we are writing. So mg into L by 2 sine theta equal to ml square by 3 into alpha. Simplify, you'll get this as the answer. Okay, if you will put theta as 53 degree, you'll get the answer of that question. If you will put theta as 53 degree, because the angle is with the vertical. Angle is with the vertical, na? That's why. So if the angle with horizontal was 37, definitely the angle with vertical is 53 degree. So you can try that. 6g by 5l should be your answer. 6g by 5l. Let's put theta equal to 53 degree. So sine theta, sine 53 degree is how much? Sine 53 degree will be equal to how much? 4 by 5 it will be. Put that here. Put sine theta as 4 by 5. You get the answer same. 6g by 5l. आता है? Yes, that's it. Okay, very good. Yes, that's a general question. Okay, now let's try this one where you have the mass placed on the inclined plane and you can either try to write F equal to ma for the block and tau equal to I alpha for the pulley, or you can also go by driving force minus opposing force upon. I'll just show you the formula. Even I can't write that much. So whichever you want to use, you are free to use. Okay. I personally don't rely blindly, or I'm not very sure of this formula all the time. So personally, as a student, I don't apply this formula, but it is applicable here, is what I can confirm. Okay. So I'm giving you guys full 90 seconds for this. Question has given us the mass. It has given us the value theta of the inclined plane. The pulley is going to rotate like this. Okay. And when the mass comes down, the pulley rotates with an acceleration alpha, angular acceleration alpha, which is equal to a by r. The mass of the pulley is given. The radius is r. Mass of the block is given. Okay. Time starts for 90 seconds in 3, 2, and 1. Mass of the block is given. Okay. Time starts for 90 seconds in 3, 2, and 1. $50 seconds more. Okay, last 5 seconds. I'm sure सबने शॉर्टकट से किया होगा, सबने इससे किया होगा ना. तो ड्राइविंग फोर्स ऑप्शंस देख के समझ में आता है. mg sin theta is the driving force, correct? So 6g sin theta is the driving force. There is no opposing force. Okay, there is no opposing force. The mass of the block is 6 kg and the value of moment of inertia by r square is m by 2. M by 2 is also 6, right everyone? mr square by 2 is mr square by 2 divided by r square. That's basically m by 2. This is I by r square. So that value comes out to be 6. So what am I getting? Answer is option D directly then. Answer is option D. This is g by 2 sin theta. Okay. Yes, formula works very well, absolutely. Okay. This was the diagram. बिल्कुल होगा, हर पुली क्वेश्चन में एप्लीकेबल होगा अंशु, बट तुम्हें अप्लाई करते आना चाहिए. जैसे यहाँ पे ड्राइविंग फोर्स है, mg नहीं है, mg sin थीटा है, ये पहचानने आना चाहिए. देयर इज नो अपोजिंग फोर्स, ये पहचानते आना चाहिए. ना ना, नो एक्सेप्शंस. केमिस्ट्री थोड़ी पढ़ रहे हैं. What do you ask to prefer equation or formula? If I'm confident about application of the formula, if I practice it, I will go by the direct formula, the direct shortcut trick. But if I'm not very confident, I will go by the equations, because equations are foolproof. They'll give me the correct answer always. Okay. सर ये एनसीईआरटी में है क्या? एनसीईआरटी तुम्हारे पास होनी चाहिए, मेरे पास होनी चाहिए. एनसीईआरटी तुम्हारे पास होगी या मेरे पास होगी? डेफिनेटली तुम्हारे पास होगी. तो उसके पेजेस पलटने की मेहनत कौन करेगा? तुम करोगे या मैं करूंगा? मेरे पास तो नहीं है एनसीईआरटी. ओके. तो मैं स्टेप्स बता देता हूँ. गो टू दैट शेल्फ जहाँ वो एनसीईआरटी है, उसको निकालना, उसको पहले अच्छे कपड़े से साफ करना, क्योंकि उसमें बहुत सारा डस्ट होगा. तुमने उसको अभी तक उठाया नहीं है क्योंकि फॉर लास्ट 6 मंथ्स. उसको बढ़िया साफ करना, ऐसे करना, तो क्लीन हो जाएगा. देन उसके बाद में केयरफुली उसके पेजेस को पलटना. Go carefully, because if you will do it fast, that book has been not opened for such a long time that if you will try to do this fast, the papers might just simply get torn apart. Okay? Yes. So be very careful. हाँ, बिल्कुल म्यूजियम वाली बुक वाली हालत है तुम्हारी एनसीईआरटी की. चलो, so practically the session is done here, but I'm not done. Okay? I'm taking you to the next class. Be with me for next 10 minutes. We are going to cover something which will help us attend our next session. Will become peaceful if we learn a few things today. Okay? चलो guys. So now we are picking up from next session. This is coming from the next session. Ideally यहाँ thank you हो गया था, तो उसे delete कर दिया मैंने अब. Now we are going to learn angular momentum. Okay, angular momentum is represented by capital L first of all, and it does the same job as, or rather similar job as it is done by linear momentum. That means what? If I take you back to this page. So in this list, if I add linear momentum here, this job will be done by angular momentum here. Okay. So what used to be linear momentum? Linear momentum used to be the measure of the amount of motion in the body. That means how much motion a body contains when it is moving is measured by the linear momentum. In fact, I remember giving you this example that if we compare a bullet which is moving very fast and a train which is moving very slow, they may have, they definitely have a different velocity, but they may have the same value of momentum. But it is impossible for any normal human being to stop a moving bullet and a moving train, except that person is Rajinikanth. Nobody can stop it. So that is only to give us the idea about the amount of motion that is possessed by a body. Just imagine things now being rotated. That means what? If something is rotating, it is basically how strongly the rotational motion is possessed by the body will be measured by the angular momentum. And angular momentum is actually defined separately for a body which is a point mass and a body which is a rigid body. Okay, so first thing first, guys, let me first give you the idea that how do we define angular momentum. So angular momentum, okay, I'll write it down. It is defined as the moment of, or it is defined as the angular effect of linear momentum. That's first definition. Okay. Also, it can be defined. अभी दिखाई देगा तो मेरे को क्या होगा अभी. It is defined as the angular word गलत है, rotational effect बोल देना चाहिए. So it can also be defined as the moment of linear momentum. Okay. By that, what do I mean? I'll explain that also. These are the two ways in which you can write that. So the way we used to write torque as R cross F. Okay. Okay. Similarly, these are the two ways in which you can write that. So the way we used to write torque as R cross F. Okay. Similarly, angular momentum is going to be R cross P. Means what? If there is an object which is rotating and has, this is first we are defining for point masses. So there's a point mass which is moving with a momentum P and is moving at a distance R from the axis of rotation. So maybe a body is moving in a circular path, okay, and say it is currently here. So this body will have its linear momentum P acting at a distance R. So we can say that due to this rotation, the angular momentum is going to be R cross P. We can also write it down as R cross M into V. That means what? M into R cross V. This is also how you can represent angular momentum. Means magnitude is going to be MVR sine of theta, or R into P sine of theta. This is the basic definition of angular momentum. Okay, so this is written for a point mass. Okay, for a point mass. But it is not necessary that your point mass has to move in a circle only. We can define it for a body which is moving in a straight line also. We will require it also. So next slide is very important. Please pay attention to it. So say if there is an object, a point mass, which is moving in a straight line with a velocity v, and it continues to do so. It continues to do so along this line only. So this mass is continuously moving along this line. And say point P is my reference point. That means my point of, you can say virtually the axis of rotation. Okay. So at this point, if I say that the point mass is moving and I want to write its angular momentum, I can always write its angular momentum. All I need is the value of R for it. So if I have the value of R, I just have to take the cross product with it. Okay. So when the body has moved forward in this line, you see that when this body is moving in the straight line, if I drop a perpendicular, this is like line of action of the motion. Just like we were talking about line of action of force, the line that you see, the red line which is along x-axis maybe, that line which is parallel to x-axis is like line of motion of the body. On that line, if you drop a perpendicular, okay, on that line if I drop a perpendicular, okay. So guys, can I say that the perpendicular distance from this line is always a constant when the body is moving along the straight line in the chat box? Let's call it D. Okay, let's call it D. So as the body will keep on moving to different points on this line, definitely the position vector R will keep on changing. The position vector R will keep on changing. As you can see, when the body was here, the position vector was D. When it has come to point P, the position vector looks different. Now, if the body reaches further ahead, somewhere here, the position vector becomes even. Okay, it has become even bigger. It has become R dash maybe. But everybody, can I say that all these R vectors, yes, all these R vectors are behaving like the hypotenuse of right angle triangles? O, Q, P, O, Q, P dash, all of these are right angle triangles? Yes or no? All of you, everybody. And in that, can I say the value of theta is changing in such a way? The value of theta is changing in such a way. Can you people tell me what D is going to be? Say in triangle OPQ. In triangle OPQ, how do you write D? Can I say it is going to be R sine theta only, nothing else? Perfect. So let's try to write down the angular momentum for this particle which is moving along a straight line. Okay. L, as we have defined it to be R into P into sine of theta. Can I say R sine theta can be clubbed together and multiplied with P? So what do I get angular momentum as? I get it as P into D. Getting it, all of you? And the more important part is the particle continues to move along this line. The value of theta changes. It becomes R dash sine theta dash. Okay. Or just to make it easier to correlate, let's write down this as alpha. So can I say it is R dash sine alpha? आदित्य शर्मा, ये लिखने की जो हिम्मत है ना, ये लिखने की जो हिम्मत है तब आती है जब माइक्रोफोन काम नहीं करता है. ये मैंने बहुत कॉमनली देखा है. ये लिखने की हिम्मत तब आती है जब माइक्रोफोन काम नहीं करता है. दूसरी बात, अगर तुम बोर हो भी रहे हो तो मैं तुम्हें क्लास में जबरदस्ती बिठा के नहीं रख रहा हूं. आई एम नॉट कीपिंग यू इंटैक्ट इन द क्लास बाय बाइंडिंग यू टू अ चेयर. यू कैन सिंपली क्विट द क्लास. ओके, everybody, please pay attention. Do you see that different right angle triangles have different values of these alphas? This angle, this is alpha, this is theta. But what is important to see that all of these hypotenuse have the same opposite side, that is D. What I'm trying to tell you guys, if this particle is moving in the straight line, and if I ever have to write down its angular momentum, I will only write the angular momentum as M into V into D, which is the perpendicular distance. I will always write the momentum as M into V into D, which is going to be the perpendicular distance of the line in which the particle is moving. Now, why will I require that? Why this slide is very important? Why this slide is very important is, next time only we will solve questions, and one of the questions which most of the time come in JEE examination is, you will have a rod which is hanging, maybe its mass will be given, length will be given, and then you will have a bullet of mass small m moving with a velocity v, and it will be moving and will collide with the rod. Collision will come, and it will maybe stick to the rod, may not stick to the rod. Question will ask you that if say the rod penetrates and sticks to the rod, with what angular velocity that the system will start to rise, and at what height the system will go and stop. So they will ask you all these questions, and we will solve these questions. So that is where we will require to write down the law of conservation of angular momentum. As we have solved already the law of conservation of momentum, here we will have law of conservation of angular momentum. Okay, so that is why we will require the angular momentum to be written, and that is why one of the most important slides of this chapter this may look boring to people like, I don't remember the name also, this may look boring to some people, but eventually, yes, people like Aditya will eventually be sad when they will not understand solving questions like these. Okay, all of you, so this is the part which I wanted to explain as the angular momentum part. Okay, so we'll just write it down. And the second is going to be the angular momentum of a rigid body. The way we write the linear momentum as mass into velocity, the counterpart is angular momentum, the counterpart of mass is moment of inertia, and the counterpart of v is omega. अरे मुझे कोई तकलीफ नहीं है, तुम्हें टॉपिक बहुत बोरिंग लग सकता है, absolutely acceptable, but why do you have to actually type it on the chat box again and again? That is more boring. You can just stay quiet, or you can simply just close the app. Nobody is forcing you to watch me. And the guts only come when you do not have the microphone. I've seen that, very common. Are we clear with these two, all of you? The way we will write angular momentum. Okay. ये वाला part मैं next time explain कर दूंगा. I'm not explaining this now. The third part also is there. Let's solve one or two questions so that we understand this better. Okay. We will come to that part. Don't worry. We will explain. We'll study this in the next class also. I just don't want this last 10 minutes also to go waste. That's why let's solve some questions quickly. Okay. Quickly, have a look. Everyone, if there is a mass m which is moving with a constant velocity u parallel to x-axis, can we say its angular momentum with respect to origin will be 0 or constant, or it will increase or it will decrease? Quickly answers in the chat box. The angular momentum will be mvr sine theta, and this sine theta, r sine theta value is d, and that value is not changing, so this value will remain a constant. Okay, please remember this point. This is one of the most important part in the concept of angular momentum. Okay, the next one, it says that we have to find the angular momentum of the body is given. Its rate of revolution is 10 cycles per second. 10 cycles per second. Omega is 10 into 2 pi. Can I say 20 pi radians per second is the value of omega? So you have to calculate the moment of inertia of the body about the axis of rotation. That means L equal to I omega. It is cycles per second. That means number of rotations per second. Pradipta. So moment of inertia will be L by I. So just put the value numerically. Yes, cycle per second is RPS only. So putting up this, we get the answer. Okay. Oh, the revolution is 10 cycles per second. My bad guys, my bad. हाँ मैंने गलत लिखा ये फ्रीक्वेंसी नहीं थी, ये एंगुलर फ्रीक्वेंसी नहीं थी, नहीं वहां पे भी गलती हुई और ओमेगा के फॉर्म में भी गलत हुआ. एवरीवन, what is given to us is only frequency. My bad. This is only the frequency, not the angular frequency. We'll have to convert it into angular frequency. So we know that frequency is 1 upon time period, and 1 upon time period can be written as 2 pi by omega. So can I say omega will be equal to 2 pi f? Good enough. So L value is given, frequency is given. So we converted and we found the value of omega. Omega comes out to be 2 pi f. 2 into pi into f comes out to be the value of omega, and we found the value of I as L by omega. L is 31.4. This value simplify करने पर numerical value will come out to be 0.5 kg per kg meter square. Okay. हाँ मैंने भी यही लिखा था 10 cycles per second. मैंने cycles के लिए 2 pi कर दिया था. हाँ correct. I did not pay attention to that part. But practically 10 cycles per second means frequency. It actually means frequency. So you'll have to convert it into angle by angular velocity by multiplying it by 2 pi. ठीक है. इसके क्वेश्चंस हम नेक्स्ट टाइम सॉल्व करेंगे एज क्विज. यस यू कैन आस्क योर डाउट्स नाउ. ओके वेट अ मिनट, एक मिनट. हाँ क्लास इज ओवर. We'll solve more of questions from angular momentum. The third explanation of angular momentum will also be given in the next class. There is third condition. We have seen two conditions. One is when a body is moving as a point mass. The other is when a rigid body is rotating I omega. The third one is when a body is rotating as well as moving forward. That means like pen fight. So pen rotates as well as moves forward. So how do we write angular momentum is something that we'll learn next time. Okay. As of now, the leaderboard for all of you. Well done. Congratulations to all of you. Okay. And I will only give you Rocket Man today. Nothing else. Let's save some time. Okay. Okay. So this is for all of you, except for those who are getting bored. That's it. So those students who want to exit can exit without writing that you are getting bored. Okay. And class teachers, if you are done getting bored, you can also exit the class. That's good, Aditya. Go ahead, Aditya. Go ahead. Getting bored. Okay. And class teachers, if you are done getting bored, you can also exit the class. That's good, Aditya. Go ahead, Aditya. Go ahead. Sir, do you play PC games? No. Today's class was awesome. Thank you. I'm getting bored. Very good. Lol getting bored trend. हाँ आज से वही trending पे जाएगा हमारी class में. Sir, don't ignore whole fans plus please. Sir, which topic to revise for next class? Nothing. Just be in the class regularly. Sir, can you show me the last slide? This one is the last slide. Sir, buy JEE and leak paper. Should I not buy IITs directly? Sir, we need to do NCERT. नहीं NCERT क्यों करनी है तुम्हें? NCERT तुम्हारी टेक्स्ट बुक थोड़ी है. वो 10th स्टैंडर्ड के बच्चों के लिए हेल्पफुल है ना, तुम्हारे लिए थोड़ी है. मत करना. स्कूल के एग्जाम से मार्क्स मिल जाएंगे. ये सारे. हाँ. अरे यार. कोई क्वेश्चन ही पकड़ लेते हैं चलो. लास्ट क्लास में थे तुम? इसको ठीक से चलते हैं एकदम एंड में और एक्सप्लेन करते हैं. तो दो स्टेप्स बताऊंगा, याद रख सकते हो स्टेप्स. तो सबसे पहला स्टेप जो याद रखना है वो ये कि फोर्स के ऊपर नजर रखो. ये फोर्स का डायरेक्शन तुम्हें दिखाई दे रहा है. ये फोर्स वेक्टर है. हाँ जो वेक्टर है, तो इसको क्या करो, इसकी लाइन ऑफ एक्शन बनाओ. इसे बोलते हैं लाइन ऑफ एक्शन. लाइन ऑफ एक्शन का मतलब है वो लाइन जिस पे फोर्स का वेक्टर रखा हुआ है. उसे कहते हैं लाइन ऑफ एक्शन ऑफ फोर्स। ठीक, अब एक्सिस ऑफ रोटेशन पे जाओ, दिस इज योर एक्सिस ऑफ रोटेशन। एक्सिस ऑफ रोटेशन पहचान पाते हो? तो वहां से इस लाइन के ऊपर एक परपेंडिकुलर ड्रॉ कर दो लाइन ऑफ एक्शन ऑफ फोर्स पे, तो हर बार एक ट्रायंगल बनेगा ही बनेगा, और वो ट्रायंगल भी राइट एंगल ट्रायंगल ही बनेगा क्योंकि तुम परपेंडिकुलर ड्रॉ कर रहे हो। तो ये जो परपेंडिकुलर तुमने ड्रॉ किया ना, इसका लेंथ तुम्हें पता लगाना होगा, जो परपेंडिकुलर तुमने एक्सिस ऑफ रोटेशन से ड्रॉ किया। ठीक है, तो ऑलरेडी ऑलरेडी हाइपोटेन्यूज पता होगा आर, ये हर बार पता ही होगा तुम्हें, क्वेश्चन में दिया होगा। ठीक है, या अगर ये नहीं दिया होगा तो क्वेश्चन में डायरेक्टली डी देखा होगा, तुम्हें पहचानना होगा। ठीक, या तो क्वेश्चन में आर दिया होगा, तुम्हें डी खुद निकालना पड़ेगा, या डी देखा होगा तुम्हें पहचानना होगा। हाँ, तुम्हें पहचानना होगा कि वो डी दिया है। कैसे समझ में आता है? जो फोर्स का लाइन है ना, वो उस लेंथ से परपेंडिकुलर दिखेगा हमेशा। ठीक है, तो बस तुम्हें फोर्स को डी से मल्टीप्लाई करना है, तुम्हारा टॉर्क आ जाएगा। एफ को डी से मल्टीप्लाई करना है, आर से नहीं मल्टीप्लाई करना, क्योंकि कर तुम अभी भी वही रहे हो, टॉर्क का वैल्यू अभी भी तुम लिख रहे हो आर इंटू एफ इंटू साइन थीटा लिख रहे हो अभी भी, यही है बेसिक डेफिनेशन ऑफ टॉर्क। लेकिन अब तुमने आर साइन थीटा का वैल्यू निकाल दिया अलग से। इस राइट एंगल ट्रायंगल में जो डी है ना, वो आर साइन थीटा ही है और कुछ नहीं। ये है अपना वो ट्रायंगल, तो मेरे पास वेक्टर्स के चैप्टर से नहीं जुड़े होता है। तो मान लो ये एंगल हमारा थीटा दिया हुआ है, सॉरी ये एंगल थीटा दिया हुआ है, कोई सा भी एंगल थीटा दिया हो सकता है। ठीक है, तो ये वाला एंगल अगर थीटा दिया है और मुझे डी निकालना है, तो इस राइट एंगल ट्रायंगल में डी इज आर साइन थीटा ओनली। बात समझ में? तो यही एंगल हमें यहाँ पे 30 डिग्री देख रखा है, थीटा इक्वल टू 30 डिग्री। बढ़िया। अब जैसे ये जो सवाल था ना, इसमें देखो ये आर दिया हुआ है एल बाई टू, आर दिख रहा है एल बाई टू, और उसका डी जो है वो एल बाई टू कॉस थीटा इस बार, राइट एंगल ट्रायंगल दिखाई दे रहा है। तो इस बार डी का वैल्यू एल बाई टू कॉस 37 डिग्री है। पर लाइन ऑफ एक्शन ऑफ फोर्स को देखो, ग्रीन वाली लाइन, उस पर परपेंडिकुलर ड्रॉ किया तो डी मिला। तो मुझे कुछ भी देखना, मुझे तो एमजी और डी से मतलब है। अब वो आर साइन थीटा होने दो, आर कॉस थीटा होने दो, वो एंगल्स पे डिपेंड करता है, मुझे बस वैल्यू मिलनी चाहिए। ठीक है, चलो बहुत बढ़िया, ओके ओके। यश रिप्ले, रिप्ले देख लेना बच्चा। अरे तुम लोग टाइम पास क्यों कर रहे हो चैट बॉक्स पे? क्विट द सेशन, गेट आउट। हाँ मन, क्या? अरे एब्सोल्युटली फाइन, तुम बताओ, बोलो। स्लाइड नंबर 33 पे था, हाँ आने दो जरा, स्लाइड हाँ ये आ गई, यही थी ना? क्या? तो सिंपल बात तो है एग्जैक्टली, तो टॉर्क लाइन बेसिकली पुली उसने थोड़ी रोटेट कर रही है कि वहां उसका खुद का वेट भी है। ये देखो, ये पुली है, ये रोटेट कर रही है क्या? कर रही है, क्योंकि एक्सिस ऑफ रोटेशन और एमजी दोनों की लोकेशन सेम है। लेकिन अगर मैं एक्सिस ऑफ रोटेशन चेक कर दूं, अब मैंने हिंजिंग पॉइंट चेंज करवा लिखा, आपने रोटेट करेगी पुली, क्योंकि अब एमजी एक्सिस ऑफ रोटेशन से पास नहीं हो रहा है, एमजी यहाँ है और मेरी फिंगर्स एक्सिस ऑफ रोटेशन है, तो रोटेशन होने दिया तो होता है, बिकॉज ऑफ एमजी टॉर्क लगता है, बस, है ना? थैंक यू, ओके गुड नाइट। सर व्हेन विल वी से इट इज एंगुलर फ्रीक्वेंसी इन द लास्ट क्वेश्चन? जब क्वेश्चन बोलेगा आरपीएस, नंबर ऑफ मतलब जो यूनिट्स है वो रोटेशन पर मिनट या रोटेशन पर सेकंड दी होगी मुनीश, तब हम बोलेंगे वो एंगुलर फ्रीक्वेंसी है। ओके, यस विशेष, बोलो। नो, यू नॉट ऑडिबल, टेल मी नाउ, टेल मी व्हाट। अनिल कुमार तिवारी सर, आई एम स्पीकिंग टू द सेम स्टूडेंट, बोलो। व्हाट अनिल कुमार तिवारी सर, आई एम स्पीकिंग टू द सेम स्टूडेंट, बोलो। एंड वेयर इज दैट पुलिस स्ट्रिंग स्टार्टिंग फ्रॉम? ओके, so the other mass is hanging here. Where is the mass? Is it hanging or what else is the situation? Are the block which is connected to? Is it the diagram which I'm drawing the correct diagram? Okay, like this. Okay, the pulley is attached to a long rod. Okay, This is the diagram. That's it. Which book this question is from? Which book this question is from? This is school homework, and you are asking me to do the school homework for you. I'm not solving it for you. I'm not solving it for you. Sorry. This is not something which you are supposed to ask me, and that too from a chapter which was done 3 months back. Be it. Please ask it on the doubt app. Okay, Vishesh? You yourself don't try the question, and you are asking the questions here after that too, 2 months after the chapter is done. Because your teacher in the school are asking this question to you to do, you are getting this done from me. Huh? What did you try? You tell me. I'm uncamming you. You have a camera on? कहाँ गया विशेष? अरे uncam क्यों नहीं होने दे रहा भाई? हाँ, audio plus video. Yes, Vishesh. Show me what you have done. Bring it. Bring it. Bring it. Bring it. I'm not drawing everything that you're telling me. Show me what you have done. Bring it down. So what? Leave it. Why? So go pick. Leave your laptop here. Go quickly pick. Fetch your book. Fetch your notebook. Quickly. Okay, Aryan, एक minute. Hridaya, Hridaya, are you there? Do you understand that when the blocks will move, they will accelerate, their speeds will change? If the blocks ka speed will change, then definitely the pulley ka speed will also increase or decrease, means change, means pulley will also accelerate. Yes. So that simply means the pulley has to have an angular acceleration which is non-zero. Angular acceleration of the pulley has to be non-zero. Do you agree with me? Right? So if my pulley has both the tensions acting on it, which are possibly going to try to rotate it, if both of them are equal in magnitude, can I say the net torque acting on the pulley will become zero? Hridaya? Hridaya? Yes. And if net torque acting on the pulley will become zero, then tau equal to I alpha says that alpha will become zero, which is contradicting to the point which we are actually starting from. That pulley has to accelerate. That is why the tension on right side, the tension on the left side have to be different. Sir, why can't we use ICOM plus FD square in slide 20? Slide 20, slide 20. What, Munish, I did not understand. Munish, बात नहीं समझ में आई. But axis of rotation is not moving. Axis of rotation is not changed. Axis of rotation is there only. And what you are saying, it is found or it is used when the axis of rotation is changed, or rather we do not know the moment of inertia about that given axis. Then only we use this. Like I'll tell you where we use this. If my rod is rotating about its center, if the rod is rotating about its center and I use this, then I will be saying it is 1 by 12 ml square plus ml square by 4. When you shift the axis of rotation by L by 2, and now this is the new moment of inertia that I want to find out. So that is where we got 1 by 3 ml square, no? So now I'm actually free to use this formula now because I found the moment of inertia. So I found the moment of inertia about this axis, which is now given to me in this question. If I was not aware of the formula 1 by 3 ml square, then using the parallel axis theorem will make sense. But I already know the moment of inertia 1 by 3 ml square. That's why. Okay. So next. Yes, Vishesh. Bring it closer to the camera. Or you have just drawn the diagram. What is it that you have solved? Acha, tell me, what will I do it in the, as per you, what will you do in the diagram? What is it that the question wants you to find out? Not audible. Hmm. And taken by who? Where is the ball in the diagram that you have made me drawn? Ah, thank you. Okay. I'm not understanding the question. You have to explain me the question. Mm-hmm. So what did you do in this question? Explain me. I want you to tell me the logic, not how you approached it by mathematically. What do you understand with the question, first of all? Is the diagram perfectly the one which is drawn in the book? Perfectly the one which is drawn in the book. When I say perfectly, everything is exactly how it is. Capital M or small m. And the ball is n times the mass of the rod. Perfect. And right now, what is the gap between these two? And what did I ask you? Is it the same diagram? And you said, yes, sir, this is the same diagram. What is my assessment here? That you haven't even tried the question, because you haven't even understood the question so far. You have to try it one more time. You have to try it 3 times at least by yourself. You have to find out what is the tension here, what is the tension here, correspondingly what are the tensions here, and then you have to find out the value of acceleration of this thing, find out the acceleration of this thing. Maybe this is A1, maybe this is A2. If you get the relative acceleration between A1 and A2, then try to make one of them stationary and try to make the other one move with respect to the first one. And then you'll be able to find out that relatively, if my ball is moving L distance with respect to the rod, whichever be the direction, I'm just trying to give you the approach. Whatever be the direction in which the ball is moving, you need to find out the acceleration of the rod, acceleration of the ball. You need to find out relative acceleration of the ball with respect to rod. So assuming this is at rest, the ball initially was here, it is going to go up. Relatively, it will travel a distance L. You will know its relative acceleration, and if, and most likely this will come out to be a constant, so you will apply L is equal to ut plus half at square. It is asking you to find out the time, I guess. Not audible. It is asking you to find out the time in which it will cross this length, right? That you will put. That you will put. I'm just giving you the approach. Okay, so try it. Anything else you want to ask from your school homework? And Vishesh Brahma Bhatt, you are the only person whom I'm tolerating in the class with respect to your questions from previous chapters. Okay. बाकी के लोग? हाँ शीश, गुड इवनिंग, बोलो. स्लाइड नंबर याद है क्या? एक मिनट रुको, ये भी फ्लाई व्हील है, ये वाला बोलो. पतंग उड़ाई कभी? पतंग नहीं उड़ाई? नहीं उड़ाना आना जरूरी नहीं. देखा है सामने पतंग उड़ाते हुए लोगों को, वो चक्री पकड़ी है कभी हाथ में, तो चक्री पकड़ने वाले को चक्री को पकड़े रहना भी होता है और रोटेट भी होने देना होता है. तो अब मान लो जो भी इंसान उसको थ्रेड को खींच रहा है, उसको क्या बोलते हैं? उस धागे को क्या बोलते हैं? मांझा. तो अब जो मांझा खींच रहा है उसे फोर्स लगाना पड़ेगा. ये वही फोर्स एफ लग रहा है, बस नीचे की तरफ लग रहा है. तो अब जब तुम नीचे से खींचना शुरू करोगे तो चक्री घूमेगी या नहीं, ये मेरा सवाल है. तो ये वही सिचुएशन है. बस इस समय चक्री जो है वो एक डिस्क है या एक सॉलिड सिलेंडर है, ये मान सकते हैं. ठीक है, तो चक्री का घूमना इज बिकॉज ऑफ दिस फोर्स. और क्वेश्चन में पूछा जा रहा है कि अगर जो चक्री है उसका एंगुलर एक्सेलरेशन 2 रेडियन पर सेकंड स्क्वायर आना चाहिए, तो कितना फोर्स से तुम्हें उस धागे को, मांझे को खींचने की जरूरत है. दैट इज व्हाट इट इज. आया फील? ठीक है, और बोलो. कहाँ भेजोगे तुम? भेजो भेजो, चैट बॉक्स पे भेजो. ऑडियो ऑन है, भेज दो. हाँ भाई, बाकी की जनता गुड नाइट. जाओ जाके पढ़ाई करना शुरू करो, अपना होमवर्क करो, स्कूल का असाइनमेंट करो. सर विल यू प्लीज स्क्रिबल विद अस? व्हाट इज दैट? कोई गेम नहीं खेलता. नहीं सर, फिर बोर करूंगा. ये भी बात है, बोर होने के लिए तो मेरी क्लास चाहिए. हाँ बोलो. हाँ बोलो. हाँ हाँ, प्लेस्ड इन सच अ वे दैट देयर सेंटर्स आर मेकिंग इक्वल टू ट्रायंगल. और मोमेंट ऑफ इनर्शिया किसके अबाउट पूछा है? फिर क्या पूछा है? ठीक है, तो मोमेंट ऑफ इनर्शिया ही हो गया ना यार. रेडियस ऑफ एक्शन पूछ लिया, मतलब मोमेंट ऑफ इनर्शिया का सवाल है ना. तो कौन से पॉइंट के अबाउट पूछा है? वन ऑफ द रिंग का सेंटर. ड्रॉ करने दो जरा. ये जैसे इनके सेंटर्स को मैंने ज्वाइन किया तो ऐसे एक डायग्राम बन गया. अब किसके अबाउट पूछा है? ट्राइंगल का जो सेंटर है, इसको क्या बोलते हैं? इस सेंटर को क्या बोलते हैं? जो भी बोलते हैं, मैथमेटिक्स में बोलना. अभी बात ये है कि तुम्हें इसका डिस्टेंस चाहिए फ्रॉम द सेंटर ऑफ ऑल द रिंग्स. वो निकालना आता है? वो निकालना क्या? ये तो प्रॉपर्टीज ऑफ ट्रायंगल है. अब तो मैथ्स की चीजें भी फिजिक्स क्लास में सीखोगे तो बहुत आसानी से निकाला जा सकता है. ज्योमेट्री की सबसे अच्छी बात ही है कि उसको तुम देख के भी सॉल्व कर सकते हो. अच्छा, डिस्टेंस बता दो, साइड लेंथ बता दो. साइड लेंथ क्या होगी इस ट्रायंगल की? तो आप लेंथ बता सकते हो ना देख के. और ये एंगल कितना होगा? पता ना, ये है ज्योमेट्री का कमाल, बिना दिए भी इंफॉर्मेशन दी होती है. ठीक है, और हमें चाहिए वो डिस्टेंस जो कि यहाँ पे तीनों ट्रायंगल से अगर मैं बनाने जाऊँ तो क्या मैं बोल सकता हूँ तीनों के मीडियंस जहाँ जाके मीट करते हैं वो सेंटर बनता है. तो ये एंगल 30 डिग्री होना चाहिए कि नहीं? तो ये 30 डिग्री, ये 30 डिग्री. तो ये छोटा वाला राइट एंगल ट्रायंगल अगर मैंने पकड़ लिया तो भी मेरा काम हो जाएगा. और उसके अलावा भी अगर मैं करना चाहूँ तो फिर काम करता है. लेट्स डू वन थिंग. पहले तो हम पता लगाते हैं ए बी डिस्टेंस. तो ए बी डिस्टेंस जो है वो 2r, ए बी डिस्टेंस कहलाएगा 2r sin 60. यस और नो? ये तो समझ में आता है. तो 2r √3/2 हो गया, मतलब ये r √3 है. ए बी डिस्टेंस, ए बी तो मिल गया. अब ए बी में से अगर मुझे ओ बी मिल गया, ओ बी, तो मैं ओ ए निकालूंगा और मुझे ओ ए की ही जरूरत है. ठीक है, तो अब ये छोटा वाला ट्रायंगल जो है इसमें क्या मैं बोल सकता हूँ ये डिस्टेंस r के बराबर है और ये राइट एंगल ट्रायंगल है और मुझे ये वाली साइड चाहिए, तो मुझे tan 30 डिग्री की जरूरत पड़ेगी. तो tan 30 डिग्री कैसे लिखूं? ओ बी बाई आर, एंड ये वैल्यू होगी 1/√3. तो ओ बी का वैल्यू कितना आया? r/√3. ओके, तो ए ओ हो गया ए बी माइनस ओ बी। ए बी कितना है R√3, ओ बी कितना है R/√3। तो ये मिल गया हमें 3R माइनस R/√3, वो है 2R/√3। और अब तरीका बता देता हूँ जो जनरली मैथ्स के टीचर्स बोलते हैं कि जो ये मीडियन होती है ना, ओ बी जो ए बी जो मीडियन है, ओ इज कॉल्ड सेंट्रॉइड। सेंट्रॉइड ए बी लेंथ को 2:1 के रेशो में डिवाइड करता है हमेशा, और ये वही रेशो निकल के आया। ये ए ओ लेंथ जो है वो 2R/√3 आई, और बी ओ लेंथ यानी कि ओ बी लेंथ R/√3 आई थी। तो तुम इन दोनों का रेशो देखोगे तो 2:1 आता है। ठीक है, तो मिल गया डिस्टेंस। अब हमें चाहिए होगा मोमेंट ऑफ इनर्शिया ऑफ द रिंग अबाउट एन एक्सिस पासिंग थ्रू ओ एंड परपेंडिकुलर टू दिस। तो पैरेलल एक्सिस थ्योरम लगानी पड़ेगी। तो पैरेलल एक्सिस थ्योरम लगाने के लिए मोमेंट ऑफ इनर्शिया आएगा, पहली बात तो किसी एक रिंग के लिए लिख रहा हूँ, अबाउट द नॉर्मल सेंटर होता है m² यूजुअली, और आप कितने डिस्टेंस से शिफ्ट कर दिया हमने, ए ओ, ये हमारा डी डिस्टेंस है, तो m² प्लस md स्क्वायर कर रहा हूँ, सो दैट इज mr² स्मॉल r लिख रहा हूँ, और ये m इसका स्क्वायर किया तो क्या मिलेगा 4r²/3, करेक्ट। तो ये कितना हो गया टोटल, 3 + 4 7 mr²/3। ये एक रिंग के लिए आया। आई नेट आएगा कितना, 3 टाइम्स दिस वैल्यू, तो आंसर है 7 mr²। ठीक है, और रेडियस ऑफ गायरेशन चाहिए तो इसको m के स्क्वायर से इक्वेट कर देना, √7r इज द आंसर। ओके, गुड नाइट सर। डू शेप डिफॉर्मेशन ऑफ द पुलीज आल्सो अफेक्ट द एक्सेलरेशन ऑफ द मासेस? यार अगर शेप डिफॉर्म हो गया तो रोटेशन में बहुत गड़बड़ हो जाएगी। ओके, क्या एक्सप्लेन करना है इसमें हर्षिता? मैंने तो शॉर्टकट वाला तरीका भी बताया, मैंने लॉन्ग तरीका भी बताया, तुम जिससे चाहे उससे सॉल्व कर लेना। एक बार रिप्ले देख लेना भाई। ब्लॉक का फ्री बॉडी डायग्राम देखो, ये इक्वेशन बना पाओगी खुद से ब्लॉक के लिए हर्षिता? एक तो जितने बच्चों को डाउट्स होते हैं वो माइक्रोफोन नहीं रखते, मैंने देखा है। हर्षिता इज वन ऑफ देम। लॉन्ग वाला ही तो समझा रहा हूँ। mg - t = ma लिख सकते हैं, जल्दी जल्दी हाँ बोलते जाना चैट बॉक्स पे। हाँ, ये पुली रोटेट हो रही है टेंशन फोर्स की वजह से जो r डिस्टेंस पे लग रहा है, तो टॉर्क लिखूंगा T × R = I अल्फा, ये लिख लेंगे। पक्का। मोमेंट ऑफ इनर्शिया ऑफ द पुली लिख दिया, हाफ m r², और अल्फा को लिख दिया a/r यहाँ से, तो r² कैंसिल हो गया, t का वैल्यू ma/2 आ गया। इस t के वैल्यू को यहाँ पुट कर देना और सॉल्व कर देना, तुम्हारा आंसर आ जाएगा। ओके, सोल्यूशन देखना मत, यहाँ से खुद से सॉल्व करना। बाय तनिषा। हर्षिता यहाँ से खुद से सॉल्व करना है इस पेज के बाद, ये वाला पेज देखना मत, स्लाइड नंबर 42 देखना मत। स्लाइड नंबर 41 पे जो दो इक्वेशन लिखी है, एक ये इक्वेशन, इक्वेशन नंबर 1, और ये इक्वेशन, इक्वेशन नंबर 2, इसको खुद से सॉल्व करना। ठीक है, ओके गाइस, चलो लेट्स रैप अप। अनिल सर, थैंक यू सो मच फॉर बीइंग हियर टुडे। ओके गाइस, बाय बाय, गुड नाइट, बाय गाइस, साइनिंग ऑफ, सी यू ऑल नेक्स्ट टाइम, बाय।